Alright, this is a continuation of the midterm exam review, page 7. We're going to do problem number 20 in this video. Okay, I'm going to give myself some more space before I start doing this problem. Alright. Get my pen ready. Okay, the problem says that at HSBC Bank, the time to complete a transaction is normally distributed with a mean of 15 minutes and a standard deviation of 6 minutes. Okay, so let's just draw the curve right away. Okay, and our mean is 15, and our standard deviation is 6. Okay. Now the first question asks us, the top 10% of customers, meaning the customers who take the longest time, will require at least how much time to finish their transaction? Now the top 10%, the ones who take a really long time, they will take longer than average, won't they? So that 10% is going to be here. Okay, that represents 10%. And the question is asking us, what is the x value that separates that 10% from the rest of the curve? Okay? So, the first thing we have to do is we've got to find what this area would be that I'm dotting. Okay? So, we know that one side of the curve is 0.5. And we know that this little part is 0.1, okay, also known as 10%. So, just with that little simple calculation, we know that this dotted area is 0.4. Okay, now what we're going to do, after you find the p-value, okay, we're going to go to our table and we're going to look for 0.4000. Okay, we're just going to scan the middle of the table and look for 0.4000. Okay, most times you won't find exactly the number you're looking for. You'll find the closest number. So here, this is the closest p-value, isn't it? 0.3997. I'll go back and write that here just for clarity. So I'll write that the closest p equals 0.3997. That was the closest one I found in the table. And that matches up to a z value. We kind of work our way backwards to 1.28. Okay, so I'm going to write that here. That's equivalent to a z of 1.28. Okay? Now I'm not done because the question wants me to find this x value. Okay, I've found the z value. Now I've got to change that to an x value. And that the formula that we're going to use is on the formula sheet. Okay? It's here. Okay, they've even manipulated it, so you don't even need to know basic algebra. This is the formula we're going to use. So go back here. So the formula is x equals z times sigma plus mu. Okay? So we're just going to slot our values in. X equals, our z value was 1.28. Standard deviation for this problem is 6. And we're going to add the mean, which was 15. So our x value is 22.68. Okay? So that's this value here. So the top 10% of customers will require at least 22.68 minutes to finish their transaction. Now we'll go on and do part B. Okay, So part B, we're still dealing with this HSBC data. So we have a mean of 15, standard deviation of 6. And this question wants to know the lowest 5% of customers, the customers who take the least time, will require it at most how much time to finish their transaction. So the lowest 5%, okay, the people who are the fastest, they are going to take a shorter time than average. So that's how we know that this 5% is going to be on the left. So this is 5%. And the problem is asking us to find this x value. Okay, so just like before, the first step is to find the p, the area between the unknown x value and the mean. So we know that 1/2 of the curve is 0.5. We know that this is 5%. So we're going to subtract 0.05. And that gives us 0.45. Okay, so we now know that this dotted part of the curve is 0.45. That's the first step. Now the second step, we need to look in the z-table and find the closest p-value to 0.45. Let me add the zeros to the end. 0, 0. Okay, so 0.4500. Okay, good. 0.4500, it's equidistant. We find two values, two p-values that are the same distance away from the one we're looking for. Okay, 0.4500. So in this case, what I want you to do, I always want you to take the lower one. Okay, so 0.4495 is the closest p-value. Okay, and that matches up to, so we're looking at this, that matches up to a z-value of 1.64. Now, that z-value would be negative. Why? Because the x value we're looking for is to the left of the mean. Now you need to remember what we're actually doing. We're mapping the normal distribution onto the standard normal. So the standard normal, the mean is always 0. So what we are doing, we're trying to find this x value is equivalent to what z value? Well, we just found it will be equivalent to a z value of 1.64, but that must be negative because it's to the left of the mean. And we remember this is like a number line. So anything to the left of 0 would be negative. And this is important because in the third step of the problem, when we use our formula to find the x value, you know, if we don't have that z negative as it should be for this problem, we're going to get the wrong answer. So x equals, we're just going to slot the values into the formula, negative 1.64 times the sigma, which is 6, plus the mean, which is 15. And then if you do the working out of that problem, you're going to get an x value of 5.16. Okay? So this unknown x value, we have just found that it's actually 5.16. So the lowest 5% of the customers who take the least time, will require at most 5.16 minutes to finish their transaction. Okay, so that finishes page 7 of the review.